Hi, Algebra 1 students. I hope you had a good Memorial Day weekend and enjoyed having a fun time, maybe with your family and some friends, I'm not sure, and enjoyed the sunshine outside. We are starting our last new lesson of the year on probability. I hope you've enjoyed this chapter. I really like it because I think it's fun, and knowing probability can really be important for making some decisions in your life. Not critical decisions. As you get older, some of those things can be critical, but I mean, even look at the weather. The weather is based on probability. That's what they use. What's the likelihood that we're going to have showers? Or sunshine? Is it going to be 10%, 50%, 70% based on data they've had before? So probability really is important. All right, I want to give you kind of a visual understanding because we're going to be looking at different events. Up until now, we've looked at probability for one thing happening. Today, we're going to look at compound events where you have two or more events. So that would be like, I have this little baggie here and I have some paper clips in it. And some of them are black and some of them are gray. All right, so I have 5 gray in here and 4 black. So there's a probability of how likely is it that I'm going to pick a gray one. And that's what we've done before. How likely is it that I'm going to pick a black one? Well, that changes when I say if I have 2 events. So I do 2 things. So let's say, what's the chances I'm going to pick a gray one and then pick a black one right in a row without putting that gray one back? That changes things quite a bit. So I wanted you to see the visual of what's happening. And you may, we're going to have problems about marbles and pens and different things in a bag. So I wanted to give you an idea of what we're talking about. So let's say a prayer and get going. Father in heaven, I just thank you for this day. I pray you would bless all of my students, that they would have great success, they would focus and learn this material well so they're prepared for Algebra 2. And I pray that you strengthen me and help me to be the very best teacher I can be. In Jesus' name, amen. Okay, so I'm going to go to the overhead. Now, I already wrote down some of these definitions to save time. So I'm just going to read them for now, and you can copy them down and pause anytime you want to. I don't have them all written down, but I got started with it. Okay, so we need some definitions. The first one is a compound event, and that is when we combine 2 or more events using and or. Okay, so we're just talking about more than one. Mutually exclusive events. That's when they have no common outcomes. So let's say that what's the probability of picking a green marble and putting it back, and then picking rolling a 4 on a die? Those are completely different things. Okay, now we have overlapping events. You have at least one common possible of outcome of 2 or more events. So that's when there is a one of the results that could happen is the same for both of them. Okay, so mutually exclusive means they're completely separate, but they happen one after another. And then overlapping is that they happen one after another, but you could have the same outcome at least once. So now we're going to do some examples, and that will really help to give you some understanding. All right, so here's an example of mutually exclusive. Event A, rolling a 3 on a die. Event B, rolling an even number. So you can see they have no common outcome there because 3 isn't even. So let's do that, show that with a Venn diagram. Go ahead and draw the box, and then we're going to put a circle inside, and in event A, I just have a 3. And in event B, I have 2, 4, or 6. And then 1 is a possibility, but it's not favorable. It's not what I want. Okay? So remember now, we have probability is favorable out of possible. Okay? That's what I want. So when we have two mutually exclusive events, what do we do with that probability? Well, we add them together. So we have the probability of event A or B, and we add those two probabilities. Okay? So now, let's see what happens. If I have the probability of a 3 or an even number. Okay? So what's the probability of rolling a 3? Well, there's 6 numbers on the die, so that would be 1 out of 6. One favorable result possible out of 6 numbers. And then how many do I have that are even? Well, 2, 4, and 6. I've got 3 out of 6. So I'm going to add those two together. And I get 4 out of 6, which is 2/3. Okay? So if you were going to look at percent, that is actually a 66% chance that you will get roll a 3 and roll an even number. Okay? Now, let's compare that or contrast that with overlapping. Let's do that over here on our paper. So the first event is going to be roll an odd number. All right, and event B is going to be to roll a prime number. Okay? So let's see how this plays out. All right? So if I have my event A here, and an odd number would be 1, 3, and 5, right? 2, 4, and 6 are not odd. Now, with overlapping, you can see real easily how this works. A prime number, well, what prime numbers are there out of that? Well, we would have actually, 1, there's some debate about whether 1 is prime. Let's just put 1 in there for now. Okay? But also, we would have 2, because 2 is even, but it is also prime. And then what about the other numbers? Well, 4 and 6 are even, but they're not prime, and they're possible outcomes, they're just not what I want. Okay? So, now this is specifically for overlapping, so it's a different equation if you have overlapping events, all right? You're going to have the probability of A minus the probability of, or plus the probability of B minus the probability of A and B. All right? I don't want that. Okay. Well, we're going to include 1, so it gets a little tricky. But, so for mutually exclusive, I'm going to have A or B. So this is odd or prime. And the probability of rolling odd is 3 out of 6, right? And the probability of rolling prime is 4 out of 6, okay, because I have 4 here that are prime. And then I'm going to subtract A and B. So what's in the middle here? That's right here. So A and B, that would be 3 numbers. So I end up with 4/6, which is 2/3. Okay? So that's how that works. Let's do another one. Number 2. You roll a die. Find the probability that you roll a 2 or an odd number. Okay? Let's just make that a sentence. Okay? So go ahead and write that down. Now, the first thing we need to do is talk about whether is this mutually exclusive or is it overlapping, because that will affect which formula I choose. Okay? Well, let's talk about it. If I roll a 2, that is 2 is even. And odd numbers are 1, 3, and 5. So it has to be mutually exclusive. Okay? So that means I'm just going to add them together. So the probability of 2 or odd is mutually exclusive. And so that means we're going to add the probability of rolling a 2 plus the probability of rolling an odd number. So what's the probability of rolling a 2? Well, that would be 1 out of 6. And what's the probability of rolling an odd number? That would be 3 out of 6. So again, we get 4/6, which is 2/3. There's a lot of that around here, but it doesn't always work out that way. Okay, so let's do another one. Number 3. You roll a die. Find the probability that you roll an even number or a prime number. Okay, so the first question is, do we have mutually exclusive or overlapping? Well, even numbers are 2, 4, and 6. What are the prime numbers? 1, 2, 3, and 5. So they both have a 2, so it's overlapping. 2 is both. So that means I'm going to have even or prime, I have to subtract. So I'm going to have the probability of rolling an even number plus the probability of a prime number, and then I'm going to subtract even and prime where they overlap. I don't want to count something twice. Okay, the probability of rolling an even number is 3 out of 6. And the probability of rolling a prime number would be 4 out of 6, right? So, 1, 2, 3, or 5, okay? But now I have to subtract. I'm not going to have more than 7. Do you see it now? I have to subtract where they overlap, which is what place do they overlap? If I have even 2, 4, 6, and I have prime, do you see I'm going to subtract what they share, so I don't count it twice. So it's just one number. So I have a 100% chance of rolling even or prime. I will do that. Okay, Now I want you to do some OYOs. Number 1, you roll a die. Find the probability of rolling a 2 or a 5. Okay? Number 2, you roll a die. Find the probability that you roll a number less than 4 or an odd number. Okay, go ahead and work on those two. Pause the video and we will come back in just a moment. All right, let's do these. I'm going to change colors really quick. So what's the probability of, are these mutually exclusive or overlapping? Well, it's mutually exclusive because it's 2 or a 5. They don't have any result in common. So the probability of rolling a 2, I'm going to add to the probability of rolling a 5, which is 1 out of 6 plus 1 out of 6, which is 2/6, and that's 1/3. Okay? So I have a 1/3 probability of rolling a 2 or a 5. All right? So that's one event, but 2 possible results, right? Okay. You roll a die. Find the probability that you roll a number less than 4 or an odd number. Okay? I want to make that clear again. We just have one event, but we have 2 different kinds of results. So either they have a common outcome, which would be overlapping, or they don't have a common outcome, mutually exclusive. So this is for one event. We've talked about a compound event in the beginning, but we haven't done any like that yet. Okay, so first we are counting the probability in our one event of one result and one event of another kind of result. I hope that's clear. Okay, so you roll a die. Find the probability that you roll a number just once. See, there is our one event. It is not compound right now. So you roll a number less than 4. So we have an less than 4 or an odd number. Well, less than 4 can have 3 or 1. Those are both odd, so we're going to have overlapping. So then I'm going to have a probability of less than 4 plus the probability of odd minus the probability of less than 4 or odd, where they overlap. Okay, so less than 4 is 3, 2, 1, so that would be 3, 6. Probability of odd is 1, 3, 5. So this is less than 4 is 1, 2, or 3. Odd is 1, 3, and 5. So that's going to be 3/5. And then the probability of less than 4 or odd, well, that would be 1 and 3. So I have 2 possibilities there. So I'm going to subtract that. So I end up with 4, 6, which is 2/3. Okay. Now we're going to look at compound events. Okay? So when we're looking at compound events, we can have different types. The first kind is independent. And that means one event has no effect on another. Okay, and obviously, the other definition would be dependent events. When one event does affect the other or another. We might have more than one event, more than two, more than three, depends. Okay, so let's look at some examples of this. Okay, so here's our event. What is the probability of choosing a green and then a blue marble from a bag? Okay? Now, in the bag, we have, let's see. We have 4 green, 1 blue, and 2 red. Okay? So that's what we have. 4 green, 1 blue, 2 red. Okay, now we can have, what's the answer? Well, it depends. We're going to have 2 events. This is compound. We're going to choose a green one, and then we're going to choose a blue one. The question is, do you put the first marble back? Okay, so we have independent events are when we replace it. Okay, this is with replacing the first marble. Okay, that keeps it independent. Okay, so if I have 7 marbles, I take out a green one and then I put it back and I choose again. So the possible marbles in the bag are still 7, and they're still the same colors that I had the first time I chose one. All right, so what I do is I just multiply. So I have green and blue. So if I have this combination, 4 green, 1 blue, 2 red, remember probability is possible over favorable. So the possibility of picking a green one would be 4 out of 7, right? And then I'm going to multiply that by my second event. So what's the second one? Blue. And this time I put the green back. So I still have 7 marbles, all right? So then there's only 1 blue one, so I would multiply that by 1 over 7. So I end up with an answer of 4 out of 49. That's how likely or unlikely it is that I'll pick blue, put it back, and then pick green. And so that formula of P, A, and B, what I do is I multiply them. Okay? And this is for independent events. Okay, so let's look at an example of dependent, and you will see how it's different. So I'm going to go back up here, I have independent and dependent, and I have the same question. What's the probability of choosing green and then blue? But this time, this is without replacement. Without replacing the first marble. Okay? So what I'm going to do is I'm going to have P of green and blue let's see. So I want to write this differently. I'm going to try that again. I'm just going to give you the formula. So A and B equals the probability of A times the probability of B given A already happened. Okay, so that's given. G-I-V-E-N. Okay? So we're going to multiply that. You'll see how it plays out. Okay? So the first event is taking a blue one. So that's the same, 4 out of 7. Do you see how they're the same here? I started just the same. Got 4 green, total of 7 marbles. So the chance of picking a green one is 4 out of 7. Now, what's the probability of picking a blue marble? There's only one, but I didn't put the first one back. So the green one is still in there, but I have 1 less blue marble. So I only have 6 in there. So then I end up with 4 out of 42, which is 2 out of 21. Okay, so it's still very unlikely, but it's a little more likely than the first one. Still highly unlikely to pick those two things. Okay, so I hope you understand. We'll keep going and try some more. Okay, number 4. I'm going to read you a problem, and then we're going to talk about it. You take a city bus from your neighborhood to a location within walking distance of your school. The express bus arrives between 7:30 and 7:36. The local bus arrives at your neighborhood between 7:30 and 7:40. You arrive to take the bus at 7:33. Find the probability that you have missed both the express and the local bus. Okay, I'll give you a minute to write that down. Okay, so are they independent or dependent? That is going to affect my formula I use. Well, the local bus is different than the express bus. So when the express bus and when the local bus arrives does not depend on each other. So this is independent. That's important. That means I'm going to do P of A and B equals just P of A times P of B. Okay. So let's look at each one. What's the probability you missed the express bus? Well, how long were you there? You weren't there for the first 3 minutes. So what we want to know is when you would have missed it. That's the probability I want. Even though it seems like a negative event, because who wants to miss the bus? That is the probability I want to measure. So I wasn't there for the first 3 minutes. So 7:31, 7:32, 7:33. So that would be 3 out of 6. Okay? Because it's only there for 6 minutes. It's going to arrive at 1 minute during those 6 possible minutes. So you have about a 1/2 or a 50% chance of missing that express bus by arriving at 7:33. You're right in the middle. Okay, so let's look at the other one. What's the probability you missed the local bus? Well, it arrived at 7:30, okay? So if you came at 7:33, again, you missed the first 3 minutes. So the probability of that is 3, but the local bus can come anywhere in that 10-minute range. So it's possible it arrives any one out of those 10 minutes. So this is 3/10, which is about 30% chance. Now, what's the chance that you missed both buses? So we're looking at a compound event. Okay, so we have 1/2, and we multiply that by 3/10, and we multiply across, it's 3 out of 20. So actually, that's only a 15% chance of missing both buses. So you're in good shape. Probably you'll get on a bus of some kind. All right, let's do one more. Number 4. Or was that 4? Yes, this is 5. Okay. Number 4. A box contains 3 blue pens and 5 black pens. You choose one pen at random and you do not replace it, and then you choose a second pen. What is the probability that both pens are blue? Okay, so pick one. Don't replace. Pick another. And they're both blue. Okay, so do I have independent or dependent? Well, this would be dependent because I'm not replacing it, right? So then I'm going to have P of A plus P of B, and I'm going to subtract B given A has already occurred. So I'm going to